Cool. So determine the equation of the line of best fit. Oh my God, it sounds like it's horrible, but it's not because you guys have got CASs and it's going to make it very easy for you in the future. However, we do need to know how to do it by hand. So the most common method of fitting a line of best fit to a scatter plot for bivariate data is using the least squares method. This is called the least squares line or the line of best fit. The least squares regression line. The equation of least regression line is the same as the equation for a straight line, but it's usually presented in a different form. We may call the equation of a straight line as y is equal to a plus bx, right? We might have learned it as y is equal to bx plus a, but or in a different way, mx plus c, right? Whatever way you've used for this particular topic, we are going to use this particular form. So, um, just as a little note there, that's probably what we're working with. So the least squares regression line is the line that minimizes the sum of the squares of the residuals. Um, it, it essentially squares everything and figures out the gap between it, and then figures out what the average gap is, and then it goes off the average gap from each side, and that's how he gets it. You're not going to have to do that by hand, so that is all good. There are some important assumptions. For fitting a least squares regression line to data, right? So to use your CAS and apply this least squares regression line, we need to have these three things. The data needs to be numerical, right? The data, so it can't be like a category of like car colors or something like that. It needs to have a linear association, so it doesn't work for lines that are non-linear. There are no clear outliers is another important one, but we'll get to outliers a little bit later on. The equation of the least squares regression line is best given by the equation of the least squares regression line is best given by y equals a plus bx, right? So this is where we'd have our highlighter out and we're applying some information. A is equal to the y-intercept. That is A. B is the slope of the graph, right? That you might want to write in below there that would be gradient, right? So our gradient B equals gradient. Another way we would write the gradient would be, or our actual formula for calculating the gradient, y2 take y1, you would have done this before, over x2 take xy. Okay, we could also draw it, if you wanted to draw attention to the y and x, this would also be labeled as the y variable. This would be our x variable. In other words, if it was for that previous question where it was like age and height, right? We would have our age and we'll have our height, and we'd be applying those different values to that. Warning, if you do not correctly identify the explanatory variable and the response variable before you start calculating the equation of least squares regression line, you may get the wrong answer, right? If you've got them switched around, your whatever you're going up by could be completely different depending on that line. It'd have to be a very even equation for it to work out to be the same. So go back to that first page if you're doing this and just double check you've got your explanatory variable, the one that explains the other one. Are we doing a pause on that?